I want you to look at two parts. The first is an aluminum coolant crossover tube from a 2006 truck engine. Solid, dense. You could drop it off a roof and pick it up and bolt it right back on. This part was designed to last the life of the engine. The second is its replacement from a 2022 model. Same function, same location, same operating temperatures and pressures. But this one is plastic, an engineering-grade polymer, according to the manufacturer. It costs about $1.80 less to produce, and it cracks, predictably, consistently, somewhere between 40,000 and 80,000 miles. The repair bill when it does? $800 to $1,500, depending on what it damages on its way out. $1.80. That's the savings, per unit. That's what your reliability was traded for. And this isn't one truck. This isn't one manufacturer. This is an industry-wide pattern that has turned modern truck engines into ticking clocks. These are 11 trucks where plastic is going to cost you real money. And in some cases, an entire engine. Let me explain the why before I get into the what, because the why matters. Starting in the early 2010s, CAFE standards put enormous pressure on truck manufacturers to improve fuel efficiency. Every pound you remove from a vehicle improves the number. And replacing metal engine components with plastic is one of the easiest ways to cut weight at scale. An aluminum intake manifold weighs 12 to 15 pounds. The plastic replacement weighs 4 to 6. Multiply that across an engine full of components: coolant housings, valve covers, oil pans, thermostat housings, charge air pipes, and you're saving 40, 50, 60 pounds. That's measurable on an EPA test. The problem is that plastic, even glass-filled nylon, even high-temp polyamide, doesn't respond to heat cycles the way metal does. Metal expands and contracts predictably for decades. Plastic fatigues. It becomes brittle. It develops microcracks around bolt holes and sealing surfaces. And it does this on a timeline that conveniently falls outside most warranty periods. Manufacturers know this. They have the fatigue data. They made the choice anyway. Starting with the worst offender. 7-liter turbo 4-cylinder. GM's base engine for their full-size trucks starting in 2019. A turbocharged 4-cylinder in a full-size truck was already a tough sell. But the oil pan is plastic. The component that holds every drop of oil your engine needs to survive is made of plastic on a full-size pickup truck. A truck that people tow with. That goes off-road. That drives over debris on job sites. One rock. One piece of road debris. One aggressive speed bump at the wrong angle, and that oil pan cracks. A cracked oil pan can dump oil fast enough to starve the engine before the gauge reacts. Catastrophic engine failure from a component that should have been aluminum. Add the plastic coolant fittings, turbocharger complexity, and timing chain concerns surfacing past 80,000 miles. Replacement oil pan is about 300 in parts, 400 to 600 in labor. And that's if it didn't cause secondary damage. 7-liter EcoBoost. Same plastic oil pan vulnerability. Same impact risk. 7 adds plastic charge air cooler pipes, the pressurized tubes routing compressed air from the turbo. Under boost pressure and heat cycling, these pipes crack, causing boost leaks, power loss, and check engine lights. The aftermarket has already responded. Companies make aluminum replacements for $200 to $300, and they're considered mandatory in the EcoBoost community. When the aftermarket is producing replacement parts before the truck is out of its first generation, that tells you something. 5-liter EcoBoost isn't immune either. Ford's flagship truck engine, the one in the Raptor, the Limited, the Platinum, shares the plastic charge air cooler pipe vulnerability on certain years, and uses a plastic coolant crossover sitting directly on top of the engine in maximum heat. When it cracks, coolant pours onto the engine and potentially into the turbo system. Ford has revised the part. The revised version is still plastic, just different plastic. The Ram 1500 Eco Diesel, 0-liter diesel, was supposed to be the smart choice. Great fuel economy, solid torque. But the EGR cooler uses plastic end tanks, and when those crack, coolant mixes with exhaust gases. The cascade that follows can include clogged DPF systems, turbo contamination, and in severe cases, hydro-locked cylinders. The combination of diesel complexity, plastic components in high-temperature exhaust environments, and Stellantis quality control makes this a truck where you're paying a diesel premium without diesel longevity. 7 Turbo. Same engine as the Silverado. Same plastic oil pan. Same concerns. But in a smaller truck that owners push harder on trails and job sites. The Canyon AT4 and Colorado ZR2 are marketed for off-road use. With a plastic oil pan, GM is selling you an off-road truck with the most vulnerable possible material, protecting the most critical fluid in the engine. If you own one, your first modification should be an aluminum oil pan, not a light bar, not bigger tires. An aluminum oil pan. The 2022 Plus Nissan Frontier. Nissan mostly got the refresh right. 8-liter V6 is solid. But Nissan followed the trend with plastic coolant components, thermostat housing and coolant crossover, sitting in the hottest part of the engine bay. These trucks are still too new for widespread failure data, but early teardowns showed the same material concerns. The saving grace is no turbo and no direct injection, which means lower operating temperatures. That buys time. It doesn't eliminate the concern. 5-liter twin-turbo V6. This one's controversial because it's Toyota. 7 V8, a naturally aspirated iron block engine that routinely crossed 300,000 miles. The replacement uses plastic intake components, twin turbos, and direct injection. Is it going to be as fragile as an EcoBoost? Probably not. Toyota's standards are still among the best. 7 simply didn't have. When aftermarket companies are already developing aluminum replacement parts for plastic coolant components on a Toyota, they're betting demand for replacements is coming. 6. Pentastar V6. Plastic coolant T-failures. Plastic thermostat housing cracks. And the plastic oil filter housing that leaks oil directly onto the exhaust manifold. Best case, you smell burning oil. Worst case, fire risk. On a vehicle marketed as rugged and go anywhere that costs $40,000 to $60,000. Aftermarket companies sell updated housings. Jeep forums treat this as a when not if replacement. 3-liter EcoBoost. Borrowed from the Mustang, calibrated for a sports car, dropped into a truck that tows and hauls at sustained loads. Plastic charge air cooler pipes, plastic coolant routing, and a known coolant intrusion issue. On certain model years that Ford addressed with TSBs, but not a recall. When your truck engine needs a bulletin for coolant getting where it shouldn't, that's not maintenance. That's design. 3-liter V8. 3 is immune because it's a V8 with decades of history. The core architecture is proven, but the current L84 version uses plastic intake runners, a plastic coolant crossover, and plastic valve cover components that previous generations didn't. The AFM lifter issue is well documented, but the plastic coolant crossover is an emerging concern. Material analysis from high mileage teardowns shows early heat fatigue at 80,000 to 100,000 miles. This won't hit headlines for 2 or 3 years, but there are millions of these trucks on the road. 7 Hemi e-Torque. The base Hemi has a decent track record, but the e-Torque mild hybrid version adds a belt-driven motor generator, a 48-volt battery, and associated electronics that significantly increase complexity. The engine uses plastic intake components and the same coolant fittings that have caused problems across the Stellantis lineup, and the e-Torque system adds its own concerns: battery lifespan and motor generator replacement costs that a standard Hemi doesn't carry. Ram pushes e-Torque as the default because it helps their CAFE numbers. You're absorbing complexity, so Ram can meet a regulatory target. That trade-off should be transparent. Here's the silver lining. The aftermarket knows about every one of these issues. Metal replacement parts already exist for most of them. 7 run $300 to $400. Metal charge pipes for the EcoBoost trucks are $200 to $300. Upgraded coolant crossovers. Metal thermostat housings. Billet oil filter housings. The aftermarket is filling the gaps the manufacturers created. If you own one of these trucks, the smartest money you can spend is replacing the known plastic failure points before they fail. If you're shopping right now, here's the one question I'd ask. Pull up the engine diagram for whatever you're considering. Look at the intake manifold, coolant housing, thermostat housing, oil pan, and valve covers. Are they metal or plastic? If plastic shows up in more than 2 of those locations, factor aftermarket upgrades into your budget. Those components are going to need attention. Not if, when. None of these trucks are going to explode at 20,000 miles. That's not what this is about. This is about a pattern of material choices across the entire truck industry that trades your long-term reliability for their short-term cost savings. You deserve to know that before you sign a loan. I'm putting together a deep dive on the most mechanically overbuilt trucks you can still buy new. The ones where the manufacturer chose metal, chose simplicity, chose durability. Subscribe so you don't miss that one. And if you've dealt with a plastic component failure on your truck, drop it in the comments. Brand, model, mileage, cost. That data helps every person watching this make a smarter decision.